Distinguished panel, colleagues, a very good day to you all. Welcome to the fourth episode of the Future Energy Asia Energy Transition Insights series. Today, we're going to discuss the all-important role of digitalization in grid modernization. Thailand and Southeast Asian countries' electricity grids need to be smarter as their energy mix incorporates more renewable power and will continue to do so in the future. This includes upgrading an aging grid, introducing automation and technology, mitigating cyber threats, and, of course, retraining and upskilling teams. To achieve these missions, regulating agencies and utilities will need to overcome many challenges. In this webinar, representatives from the International Energy Agency, Thailand's Ministry of Energy, and the country's leading utilities and power players, including EGAT, PEA, and MEA, will join us to share their insights on what the challenges are and the best solutions that can help Southeast Asian countries achieve their goal of a modern, smart, and sustainable grid. But first of all, let me please welcome Mr. Mongkon Thangsiriwit, Cluster BVP Power Systems Thailand, Myanmar, and Laos from Schneider Electric, who are our partner and sponsor for this webinar. Hailing from a leading energy and automation digital solutions provider, Mr. Thangsiriwit will shed light on the unprecedented changes the energy sector is facing and how Schneider Electric is powering the new electric world everywhere. Over to you, sir.
Thank you, Mr. Melcha. And thank you for having me here. It's my honor to be able to join this discussion today. And hello, everyone. Yeah, first to introduce myself, my name is Mongkon Thangsiriwit, responsible for power system business, cluster VP for Schneider Thailand, Laos, and Myanmar. Yeah, I have been in Schneider for 17 years, working in various roles in power system, solar, data center, services, and also smart. Yeah, in this short presentation of 15 minutes, I would like to speak about two main areas where Schneider would like to contribute to utility sector to digitize grid utility and also to modernize the grid. Yeah, next slide, please. Yeah, quickly about Schneider Electric profile. We are proud to be a fast-growing company in digitalization. We provide energy and automation digital solution for energy efficiency and sustainability. Our presence is quite well balanced at the global level, with the revenue almost equally distributed in all the regions around the world. Yeah, and with the 40%, more than 40% in the emerging countries. And the biggest revenue is coming from Asia. We achieved 25 billion euro revenue of last year in year 2020, where we put 5% of our revenue to R&D and innovation. And it is interesting to notice that almost 50% of our revenue is coming from digitization activities. Next slide, please. Yeah, just a reminder on the trends and challenges in our new energy world. We are in more and more electric world. Yeah, that we forecast that in year 2050, the demand in electricity will increase by 60% compared to year 2020. And this poses us the challenge on how do we produce more electricity in order to serve this demand, while we need to decarbonize our electricity generation in order to avoid the climate change. We are in more and more digitized world, more decarbonized and more decentralized. The connected device is increasing at a very fast speed. And the question for the power generation and utility is about how do we leverage the digitization technology to lower the cost of electricity in order to benefit all the consumers. And with more decarbonized energy, the question is how do we maximize the renewable energy to be connected to the grid? And this is about the more decentralized energy in the form of DER. The question is how do we make the most of DER for the consumer while maintaining the grid stability and also avoiding the massive investment in the capex in order to upgrade and modernize the grid. Next slide, please. Yeah, the future energy world is about everywhere. So it's not only the grid. So it's about also on the demand side. We talk about digitized home building. In the future, data center, industries, and infrastructures for the smart city, for example. And to serve this demand, we need grid of the future. And Schneider, we are present in all the sectors in order to provide the digital technology. Next slide, please. Yeah, and this is the potential model for the new energy market. So it's not yet deployed in Thailand, but we talk about this right now almost in all the players in the market. And from this model, what we see is that utilities will play a key role to enable the new energy world. So the utility will have the mission to connect the DER and to host these renewable energies in the form of EV, solar energies, microgrid prosumers, for example. And regulators also has a key role in preparing the regulation and the mechanism for the future energy market. And in here, there will be the new market participants. So namely in the blue box, in VPP, aggregators, retailers. These new participants may be the energy trading company and SPP, VSPP people. So these are the business opportunities that coming, and utility and regulator will have the key roles in enabling these new opportunities. Next slide. And therefore, we need a digital solution in order to prepare the grid for the future. And for example, the proven digital technology today that deployed in utility worldwide. On the left-hand side, the ArcFM, which is the geographical-based solution to prepare, design, and construct the digital grid. ADMS and DERMS are the smart grid platform that enable utility for the real-time management and operation of the grid. AutoGrid is the solution for VPP and aggregator, smart metering for meter data management, Grid Advisor for the maintenance, and Energy Profiler for energy efficiency. Next slide. So those are the digital technology that help to digitize the grid for the utility. And I would like also to quickly introduce the new innovation from Schneider Electric. What we call innovation is in the air, which is all about the SF6 free technology for the decarbonized energy world. Next slide, please. Why we talk about SF6 free gas? So the reason is this is for our planet, for the climate change issue, which is today the emergency topic. So from the study, we found that 80% of the greenhouse gases emission is coming from energy production and consumption. And in the Kyoto Protocol, SF6 gas is one of the 6 greenhouse gases to be reduced. And 1 kilogram of the SF6 gas in the atmosphere equal to 23.5 tons of CO2. So this is why SF6 is really the problem for the climate change. Next slide. So why we talk about SF6 gas in our energy world? So SF6 is widely used in medium voltage and high voltage equipment. It is used as an insulator or insulation medium in the electrical equipment. That is the first purpose. And the second purpose of this gas is to use to break the electrical current inside the circuit breaker or load break switch. And all manufacturers use this gas. We all have the similar technology. Next slide, please. Next. Next slide, please. Click next. I think this is due to the animation. Yeah. Can you come back to the previous one? I think it doesn't show. Yeah. Actually, I can speak about the implication of the SF6. When we talk about 1 kilogram for the that is equal to the 23.5 ton. We can imagine that it is equal to a car that we drive for 100,000 kilometers. So the carbon dioxide CO2 that produced from the 100,000 kilometers is just from 1 kilogram, which is equal to 1 circuit breaker. And this is also equal to the travel between US and France 8,000 times. So that's why the impact to the climate change from the SF6 is quite huge. And all the geographies are already make the commitment to move away from this fluoride gas, or in our case SF6. In China, in EU, and also in the US, they all already have the commitment to move away from this gas by around year 2025 to 2030. Next slide, please. Yeah, and what is the alternative to SF6? In Schneider, we are working with the independent and specialized bodies to study what would be the alternative. There are few alternative gases that we found that it still pose the risk to the health and climate. And therefore, as the result, Schneider focused on the innovation of using the air is to replace the SF6. So what we believe is that the best gas is air. Next slide. Yeah, so our focus is to innovate the green and digital switchgear, aiming for sustainability, safety, and efficiency. And next slide, we received many international awards last year on this innovation. And the most recent one is the ICEF, which is the innovation for cool earth. yeah, which is from Japan last year. And yeah, this is a quick introduction or presentation from Schneider. And sorry, there are 2 slides that we lost the content due to the animation issue. Yeah, hand over back to you.
Thank you so much. Thank you so much, Mr. Thanks, Sirvit. Next up, I'd like to welcome our esteemed panel, which will be moderated by Dr. Kun Pirapat from the International Energy Agency, who is responsible and covers the role as an analyst for the system integration of renewables. Kun Pirapat, over to you.
Thank you, Mel, for the introductions. It's my pleasure to moderate this panel discussions with speakers from, as Mel mentioned, Ministry of Energy and 3 main electric utilities in Thailand, as well as Kun Mongkon from Schneider. We will start off by providing the opportunity for all of the panelists to give a short introductions and overview on some of the key issues in Thailand's power sector, which will be relevant to our discussion today. And after we hear from each of the panelists, then we will dive into the discussions on digitalizations and grid modernizations, which will include issues relating to the uptake of solar PV and the impact on the grid, and also the digitalization, the challenges in modernization of the grid with the uptake of variable renewables, particularly solar PV, and then the issue of cybersecurity with increasing digitalization. And of course, the new utility business models. Since we have already heard from Mr. Mongkon, so I would like to start off by giving the floor to Dr. Tawarat Sutabut, who is the Chief Inspector General at the Ministry of Energy, to provide a short overview. Dr. Tawarat, the floor is yours.
ขอบคุณครับคุณพีรพัฒน์ครับ and I thank you the DMG, the organizer of the Future Energy Asia, and well, I have a few slides just to present to you about the digital technology and its impact onto the grid and also the electricity industry as a whole. My short comment is this. The digital technology is a technology that will revolutionize the power industry around the world. So it's not just only the digitization or modernization that we have to do, but we have to expand the grid, because to have a grid ready and strong enough to move the electron from point A to point B whenever we want, wherever it will be delivered, is the mandate of all utilities in this planet. So I have just a few slides. Don't focus on my number because it's already out there. That is, we are doing a new thing. Next slide, please. But I would like just to speak a bit about what is the impact of this digitization and modernization onto the power planning of Thailand. In the past, Thailand has the methodology of performing or formulating our power generation development plan, or what we call a PDP, which become the anchor planning process of all other energy infrastructure and gas infrastructure for the country. And in our system, in which is still a single buyer, whatever is in the plan, it will be paid back by the consumers through the tariff design. So the planning can, sometimes can be wrong, because we use the forecast methodology, and then we match the demand and supply as we forecasted. But in the past many years, we never forecast it right. Either short a bit, but also most of the time we over-predict the demand. Like the situation that we have right now, the PDP, the Thailand's PDP already over-predict the power consumption by almost 10%. That would mean that we have idle capacity waiting to be dispatched. And I don't think that would be optimal way to do a business in a digital world. I think going forward, we have to change mindset. So the mindset that had to be changed due to the impact of the digital technology is the mindset of producing this PDP. Because you can see from my slides that don't focus on a number. The PDP actually started by forecast the demand, and then we matched the demand by assuming that a new power plant would be fitting into the grid, into the system on the particular year that we would like them to be commissioned on. And then after the generation has been predicted and matched, we then planning for the grid. So we will bring the grid from the power plants to the market. So most of the time that, after we not only just to oversupply the power generation, we oversupply the grid as well, because sometimes the grid is already constructed to the power plant that never been dispatched. So actually, in the digital world going forward, I think the mindset of doing this PDP plan has to change a bit. And right now, at the Ministry of Energy, we have a new plan that actually, instead of waiting for a new generation to come up, why don't we just modernize and expand the grid as much as we can, so that wherever the power generation would be, in a concept of distributed energy facility, DER, it could inject the electron into the grid and transmit it wherever it is. So that would require not only the modernization of the grid, but it requires some modification of the industry itself to shift away from a single buyer to more of the market-oriented reform in the future. Next slide, please. So not only the digital technology has the impact on the planning, but you could see that right now we work with the utilities and also the Energy Regulatory Commission, or the ERC. You can see the white box on the bottom of these slides that actually we already prepare some sandbox projects that could utilize a new concept, as I mentioned, going forward in the future, that would not just only utilize the digital technology, but also it will change or shift away from the current existing single buyer model. The new business model or a new the power trading in the future would probably include some peer-to-peer power exchange, some bilateral or private power purchase agreement, energy storage business model, some virtual power plant, and of course, everyone talk about the microgrid, nanogrid, and smart grid that embedded in the national grid. And of course, last but not least, to enhance the energy efficiency in any grid, who should enhance the new methodology of demand response, or DR. All this business model need a digital technology, and all have an impact on the power planning and also the electricity industry as a whole. Next slide, please. So going forward, Thailand will take the result from these sandbox projects, and we hope that we could come into a conclusion, and we will draw probably a new reform process of electricity industry supply in Thailand. So the single buyer model would probably be modified and allow more market mechanism to be utilized more in the new, in a new era, in which we hope that the digital technology and a new business model would emerge from this. I will stop here, and then I will entertain you more on the discussion panel. ขอบคุณครับ Back to you ครับคุณพิรพัฒน์
Thank you, Dr. Tawarat. You have touched on some of the key issues, particularly on the business models, which we will have the further discussions in today's sessions. Next up, we have Dr. Nitat Warapon Pipat, the Director of Generation and Transmission System Planning Divisions from IGAT. Dr. Nitat, the floor is yours.
Thank you very much, Dr. Pirapat. I'm Nitat Warapon Pipat, the Director of Generation and Transmission System Planning Division of IGAT. Next slide, please. Okay. Let me start trends. That is 3D. The first is decarbonization. It is the keyword in every multinational organization, and 50% of Fortune 500 companies have included decarbonization plans in their sustainable strategy. In order to limit rising global temperatures and meet the Paris Agreement, every organization in the world needs to find efficient and technology to reduce their operating costs, but also lower greenhouse gas emissions. The second D is digitalization. That is the topic today. The energy industry is facing complex challenges and rapid change. Cyclical regulations change, the large-scale integration of renewable energy and distributed energy resources, the increased cyber risk, a generation shift in the workforce, aging infrastructure and plant equipment, and business model disruption in the recent times. To address these challenges, the Internet of Things, artificial intelligence, and blockchain technology are key enablers in the power sector transformations, helping the manage large amount of data collection and analysis. Optimization also increasingly complex energy system. That is the impact of digitalization today to the utility grids. And the last D is decentralization. On a global scale, utilities are undergoing a cultural shift where they are moving away from old business model that called the centralized generation to distributed generations, and allow third-party access ownership in the future. Replacing traditional business model now gives utility new source of revenues. The right-hand side on the screen show the significant challenges and change for utilities. The aging infrastructure bring with its risk in terms of potential failure and poor environmental compliance. How are utilities to evaluate the risk and prioritize strategy for rehabilitation, repair, or replacement. The asset management is the solutions, which the asset management is the organize your business to deliver level of service at the least cost. So the asset management software and concept will be the key issue for this. And also the rest for the non-utility player come to the energy market and wholesale and retail market. The next is the changing role of system operator. So the system operator needs renewable energy forecasting and also the performance of the energy management system. That is the two requirements in the future. Information technology and operation technologies convergence, that will be an issue next. The IT and OT convergence is the integration of the information technology system with operational technology system. IT systems are used for the data-centric computing, whereas the operational technology system used for the monitoring events, process, and this process will make the adjustment in the grid as required when we integrated the renewable energy and we have the distributed resources. The last is the increasing of the cyber attacks. That is the real challenge for the utilities. When we bring the digitalization, or when we have the digital system applied in our grid, and then that is the risk that we may have the cyber attacks. We should have the team to prevent that, and we should design the cyber security system for the grid. Next slide, please. So this is the transformation of the grid. I think Kun Monkon already mentioned that some part of that already. On your left-hand side, that is the traditional or the conventional grid. The character of the traditional grid is that the centralized power generation come from the top or the high voltage level, and then to the medium voltage, and go through the low voltage level and go to the customer. We call that the one direction of power flow, and the operation based on the historical experience mainly. But when we transform to the new grid or the grid modernization, the grid we will make the grid smarter and more resilient through the use of the cutting-edge technologies, equipment, and also the control that communicate and work together to deliver electricity more reliably and efficiently. And that can reduce the frequency and duration of the power outage, reduce storm impact, and also restore service faster than ever. Utility also benefit from a grid modernized, including improve the security and reduce peak loads, increase integration of renewables, and also lower operational costs. The technologies are made possible by two-way communications, technology, control system, and also computer processing. These advanced technologies include advanced sensor, known as phasor measurement, unit or PMU that allow operator to assess grid stability as one digital meter that give consumer better information and automatically report the outage. Relay that sense and recover from the fault in the sustainable automatically. Automate feeder switch and reroute power around problems. And batteries that store excess energy and make it available later to the grid to meet the customer demand. So I think that all for this round. Thank you, Dr. Pirapat.
Thank you, Dr. Nitat, for providing the concept, the overview of digitalization and the issues. Next up, I would like to invite Mr. Pongsakorn Yuttakovit, the Assistant Governor of Planning and Power System Development from Provincial Electricity Authorities. Mr. Pongsakorn,ครับ
Swadee krap. Good afternoon, everyone. My name is Pongsakorn Yuttakovit. I'm Assistant Governor for PEA, Provincial Electricity Authority. First of all, I need to mention something about the digitalization in the grid modernizations. What is come to the digitalization? Next slide, please. Do we have the different factor to the grid modernization? My slide lost some word, no problem. I try to present. Firstly, is about the decarbonization. You know, every utility, I think just only last year or just 2 years, they have the goal to do some carbon neutrality. If you look at in the USA, you look at in the Europe, they mention this thing that Kun Mongkol says about the SF6 free, because not only the electricity production is about the process that we bring to the system. And also, even we try to reduce the carbon emission until to some limited, they need to have the carbon captures. That's the future. Second one is decentralization. It's not only the distributed energy resource. It's about something change. The payer will come, right? You can see it's not only a utility, just only the player. You will see the customer, the consumer, and then will be the prosumers. Then we change from the energy monopoly to the energy democracy. It's quite a big word. Why we say that the energy democracy? Because everyone can be do some parts of the utility. They can supply the electricity and also they can do some energy security. Depend on you create the framework for them to do. If you look at the some in the USA, they just issue some idea, some order to bring the microgrid system to use in the big grid. That is just last year that come to effective to get in the order. And last but not least, that how we can bring everyone together. That's why we need the digitalization. Based on the important issue is how we exchange the data, how the utility can exchange the data with the customer or with the consumer is a key issue. And also the problem. Problem is, you know that we have the cybersecurity problem. When the utility decide about the OT, you know, the operating technology, they try to mitigate any access, they have some security encryption. But in terms of IT, we correct all data and exchange. You know, that's why we need to have to do the OT and IT convergent. How we manage this one more efficient. It's not limited in the utilities. It might be up to scale to the market price and to the customer and to the consumer. And I didn't mention about the technology. We have the blockchain that support about the data structure. We have the AI to help the customer to evaluate what the possible solution to provide the energy to the grid. And there are many fields that the digitalization can support. Next slide, please. We did some study. If we want to move the grid modernization, it's not only the technology, it's most importantly is the policy and regulation. When we want to design the market, or we want to design something change about the process, right? The policy and regulation will come in the place. How we change the regulation, how we, get the order to everyone to understand the interesting point when we want to operate this power system. Because of that, we can enable by the digital technologies that somehow, everyone might don't understand how we, participate in the market, or how we participate in the grid. That we need to have the framework and move up. We try to relate some regulated area, right? We move from the big customer, is about the customer use the power more than 10 megawatt, and they can produce by themselves or something, and they have some, money to upgrade the system. They can use the digitalization to, understand what the grid action and how they can react when the grid change, something like that. And also from the utility side, we need many ideas to do that. I mentioned about technology is AMI, the energy storage system, the demand response management system, ETP or NETP, EV charging station management, SCADA, EMS, DMS. But somehow that is, that might be the OT technologies to use. But very importantly, that how we get the actually process to use this one in the view of not only utility, it only the view of the participant in there, just like consumer. And then next slide, please. We see the former grid structure, similar like the picture that you can show, right? You see only the player is a utility. We have power producers from IPP. We have the foreign IPP. You can share some power from Asian power from the neighboring country, Laos, Cambodia, or Myanmar, or Malaysia. And next slide, please. When we see some vision in the future, we look at there are huge change of the landscape of the electricity industry in the future, because the player will increasing. But the points on the picture that show the yellow dot line, you may see some the data exchange between utility and the consumer, the microgrid, everyone want to participate, and everyone will affect to the demand and supply of the system, and importantly that affect to the cybersecurity for the system also. That's a brief introduction for me. Back to the Dr. Pirapat. Thank you.
Thank you, Kun Pongsakorn. Next up, I would like to invite Mr. Pisanu Tanpithavorn, Assistant Governor of Technology and Material Management from the Metropolitan Electricity Authority.
Thank you, Dr. Priyapat. I would like to short brief about MEA Smart Grid. In MEA, we call Smart Metro Grid. This is our smart grid vision. is a smart power system for better quality of life and environment sustainability. Next slide, please. Next slide, please. Next slide. Okay. This is go back one slide. We have a smart grid, smart metro grid roadmap. It starts from 2016 to 2036. We divide it into 3 phases. First phase is from 2016 to this year for prepare fundamental or infrastructure for the smart grid. The second phase is from 2022 to 2031. The second phase is prepare for advanced smart grid technology. And the third phase is from 2032 to 2036. It's for investing in advanced smart grid technology. Next slide, please. We have the proposed for the first phase. The first one is expand reliability power quality. The goal is a stable power system. Many projects in this proposed. Example is SCADA and EMS, DMS. The second proposed is excellent service. The goal is excellent service. We have a mini platform for the services. And the third proposed is excellent energy. Its goal is social and environmental care. We have the microgrid or mini for the environment. Next slide, please. We have launched the pilot project. This pilot project is covered by the 4 roads. There are Peturi Road, Ratchadapiset Road, and Lama 4 roads, and Payathai Road. It covers 11,000 residential and commercial and industrial. It will allow 20,000 customers. Next slide, please. In smart microgrid system, there are five items of this pilot project. The first one is smart meter and AMI, the MDMS system. The second one is TLM system, and the third one is outage management or OMS system. And the fourth one is demand response or DR. And the fifth one is ITT integration. Next slide, please. This is a smart metro grid diagram. The green one is in the smart project, pilot project, and the blue one is the existing one. You can see the connection for the smart metro grid pilot project, and its mainly important is ITT integration, but to connect everything to for the existing one. Thank you. Back to Dr. Pirapat. Thank you.
Thanks very much for the panelists in providing some of the key issues relating to grid modernization and digitalization. Given the number of issues that we are covering, we will extend this webinar for another 15 minutes just to have discussions that covered some of the key issues. We've heard from the panelists, talking about the technology options as well as the policies. But then, of course, there are a number of issues that receive a lot of interest by a lot of stakeholders, not only in Thailand, but also in the regions and around the world as well. So the questions and also the issues that I'd like to raise and ask the panelists is that as we are moving towards a more prosumerist, more distributed energy resources connected to the system, this is one of the questions that coming from many people relating to the stability, the impact on the stability and reliability on the grid. So given that we have, three of the main electric utilities in Thailand, so I'd like to ask Dr. Nitish just to touch on this issue on stability and also reliability of the grid when we have more grid-connected solar PV into the system. Please, if you have any view on that.
Yes. Before I start about the system stability and the reliability of the system, when we have this technology or this generation that come to our grid, so we have to talk about the number of that. Refer to the Alternative Energy Development Plan or AEDP, the less at AEDP, the solar rooftop and the solar farm will account about 40% of renewable energy in 2037. That is the plan. And as everybody knows that the solar energy penetration cause the significant power fluctuation and lead to the system frequency deviation. And then the conventional power plant should activate or respond to make the balance of the power and demand. So that is the impact from the solar energy. And for the EV, that is the issue too. The EV is the significant growth in near future. The government said that in 2025, the EV will come to our system approximately 1 million, which can be separated to 40% for the car and pickup, and 60% for the bicycles, and like e-bike, and also 0.5 approximately for the truck and bus. And then when the EV come to us, they need the charging station and also need the energy, or we call that the electrifications. They turn from the petroleum to the electricity. So that is the challenge, and that is the impact to the grid stability. To make on to resolve that, we have to study and we have to make the assumptions. It is very essential to evaluate the potential of the grid and its impact due to the EV integrations, such as the load model of the EV for the power system study. In addition, EV not only had an energy demand comparable with an average household energy demand, but also had the unpredictable dynamic behavior like a moving load. Therefore, both solar energy and EV has an impact on the supply and demand balance. In the power system, electricity supply needs to be balanced with the electricity demand and loss to maintain the safe and dependable and stability of the operations. For now, after we look into our system, we confident that within 5 years, EGAT can support that demand for the EV and also the solar. But in the future, EGAT will transform the existing transmission system to the grid modernization by implement the technologies and also digitalization in the EGAT system. And now we start to make flexible power plant in our own generation. And also we have planned to make the digital substation, and we have the energy storage system to maintain the power balance and more dynamically. And also we introduce the fax device to increase the system stability in the system. So that is what we have done. Thank you very much.
Thank you, Dr. Nitat. You mentioned some very important point in terms of the role of storage and also flexible power plants. And the IEA has recently been conducting a study on power system flexibility in Thailand in collaboration with EGAT, and we will release the report in the coming weeks. So that's very interesting. Next, I would like to hear from another electric utility in the metropolitan covering Bangkok. So, Kun Pisanu, if you have any view on the issue of stability on the grid when we have more distributed energy resources, what would be your view?
Thank you. For our view is effect. Please open slide number 15. We worry about the effect of the solar rooftop. When you have the many solar rooftops installed in the feeder, the voltage in the rise was less at the end of the rise. And in the daytime, we must manage this to control the voltage system. Next slide, please. For the EV, we can't predict our customer what time they will charge their car. It's normally in the evening or the nighttime they will charge their EV. And but we can't predict and control them. Next slide, please. Here is the effect of EV. It's change daily load curve in the nighttime or in the daytime. We must balance it. Next slide, please. We worry about 3 items. The first one is reliability of the system. The second one is the cost saving in our system to affect the tariff. And finally, is the environmental benefits for the carbon or something like that. Next slide, please. We provide a smart grid component to support some solar system, solar rooftop, and EV to manage and balance source and load for electricity efficiency. Thank you.
Okay, thanks very much, Kun Pisanu. It's very interesting to hear about the smart metro grid and also the issues of, when we have more EV coming into the system. The issue of charging when we have more EVs is going to be a very important aspects to consider, as we have seen in many countries, especially in China, with increasing share of electric vehicles. So the concept of and the issues of smart EV charging has come into consideration in a number of countries in order to manage, and also the use of smart EV charging can help to accommodate more renewables coming to the system as well. Now that's bring me to the key challenges when we talk about the grid modernizations. We have heard from EGAT, we have heard from NEA. So I'd like to ask Kun Pongsakorn from the view of PEA in terms of what would be the challenge when we're moving towards transitioning towards clean energy with more distributed energy resource. we have to modernize the grid. So what would be the key challenge from PEA view?
Thank you, Dr. Pirapat. The key challenges is we might be don't know about the DR well, because of we try to think about them is alien, because of we try to protect them from the grid, because of you can see that they are when they want to push the DR into the grid, right? We try to have some function to block it, because of they will influence to impact the stability. But somehow when you think about we have the DR increasing by the solar rooftop and the EV charging station, how we can manage this? That we need to know them. The information that they get from their energy resource should be bring to the utility to manage. That you mentioned about the smart charging station, right? Smart charging station, they need to send some information back to utility to manage. That we need to have the standard and the process to manage this one. You don't be afraid of that they have some distributed generation. We need to manage, but sometimes they have some cost, because you get an MBA mentioned about the cost to mitigate the problem. And then we need to have the framework to work with them, right? When they create the problem, they need to mitigate them by their cost. That's the key issues. But somehow, the less of that, the utility will handle it. It's not handled by the who will create, but also utility need to handle it. But how we can get the framework to work with them, this is a really important point. I know that many regulators need to think about that. Is no one can handle it by themselves. We need to cooperate with them to handle it. But somehow you can see the way that we cooperate, just the trading platform, peer-to-peer trading, bilateral contact, that almost help them to transform, to help the system, to help the grid, and sharing the information when they want to dispatch the power into the grid, or they want to receive the power. That should bring the digitalization to the grid. That is my point for the challenges. And also the regulator, the policy will need to play the key important role to create the framework, create the rules for all utility and consumer or ER to work with. But somehow I understand it's a difficult part to make them understand, but the regulator create a sandbox project to make them understand that the process will clear. But should be, let's see about the progress of the sandbox, and from the result of the sandbox, we will create some framework, some rule, some regulation to help them to integrate with the grid. Thank you, Dr. Pirapat.
Thank you, Kun Pongsakorn. You touched on some of main issues in terms of regulations and also policies, which before I go and ask Dr. Tawarat, I would like to ask Kun Mongkon first, from the point of the technical challenges, how digitalization can enable more renewable energy, on utility and also commercial scales. What would be the challenge, and how digitalizations can help with this?
Yes, thank you, Dr. Pirapat. I will take a few minutes to give my answer. Yeah, with a PowerPoint. Yuan, can you show the PowerPoint for the answer? Yeah, while waiting, I would like to the PowerPoint not showing it. Yeah, I would like to just recap on the challenges that Kun Pongsakorn just mentioned about the DER. Since DER is normally not the things that connected to the grid before, so it is kind of the alien or the new things that are coming to the grid. So because of this, we expect that the utility will be able to host all these DERs to accommodate them and to be able to maximize the DER to be able to connect to the grid. And for this, it poses the challenge and potential problem to the grid in terms of the stability, because it could raise the voltage if there is no enough load. As Dr. Kun Pisanu mentioned, that this one could potentially make the grid unstable, and eventually this needs to be managed by the digital technology. Yeah, and from this model, I would like to mention again that the utility is the key enabler to host all these DERs that we say is it is in the whether in the form of a solar plant, solar home, microgrid, and battery energy storage. So for this, the platform to be used at the utility need to have the capability to manage and control these DERs real time, to be able to anticipate and to act fast to eliminate if there is abnormal situation in the grid. Yeah, and I would like to also mention that also on the other end, the new players like VPP and aggregators, these also need the digital technology, and I will mention the use case in the next slide. The digital technology that enable the aggregator to connect these DERs to the platform. And yeah, for example, the real use case of Sunrun virtual power plant in the US. Yeah, it is about the fast-growing company Sunrun, who is the leading solar home services and solar battery storage. So these are fast-growing solar home service in the US. They initially in the year 2019 has the install base of solar home of 10,000 batteries with them. And with the fast-growing activity, the question is that how to maximize the benefit of this install base for the solar home prosumer and also for Sunrun as a service company. So we look at the solution to help Sunrun to monetize their large number of install base to generate the revenue, and also to help them with the platform that could serve the highly increasing number of the install base. So it must be highly scalable. So with the VPP platform, this help to enable Sunrun to be the aggregator. So it helps to handle the service contract of Sunrun of $50 million and grow the platform from 10,000 batteries to 100,000 batteries in the next year. In 2 years, so this serves the fast-growing number of solar home. And also, this is the enterprise level, enterprise platform that able to connect to all types of the storage assets. And finally, it also helps to generate revenue for each home residential, $700 per year. So from this actual use case, we see that this digital platform help all the parties, the utilities and the participants to grow the DER, to use more renewable energies, and also this sun run also it can provide more value to their customers for the home residential to be able to generate the revenue, and also to feed the power back to the grid, which is the cleaner energy, and also help the energy to bring more value. Yeah, and this is from Schneider Electric point of view. Dr. Pirapat.
Thank you, Khun, and thank you to all of the panelists that have mentioned. We have heard about technologies, options, and also the platforms, the future platforms, experience from other countries. But now I would like to ask Dr. Tawarat just to get your view, and also in terms of what would be fitting for Thailand in terms of business models that you have already mentioned, but of course the policy and regulatory frameworks that would be appropriate in order to for Thailand, for us to move towards clean energy transitions with digitalizations and modernizing the grid. So Dr. Tawarat, the floor is yours, if you could provide some suggestions and recommendations.
Yes, well, I think one of the speakers mentioned that the digital technology is an enabler. It's an enabler mechanism that could enabling more renewable energy or DER, distributed energy resources, to get into the grid, because the nature of volatility of DER. So we need a digital technology to make sure that we can curb up with the volatility of the thing. So the demand and supply could still maintain equivalence in everywhere in the grid. So I do believe that allowing more flexibility in the grid, utilizing the capability of the digital technology, I think not just only the clean energy and distributed energy that can get into the grid, but it also will bring more business into the grid. But we need to send more economic model signal, more economic signal into the system as well. Right now, the system can get a signal of demand and supply, but the pricing signal is still limited. Maybe just only peak off peak, for example. But if Thailand needs to step away from just the single buyer into a more of the market power pool type of things, and allow real-time pricing and real-time energy trading, it could bring more business models into the system. Just to provide a few to capture this manner, the a business of energy storage. Where you store excess and cheap electricity when there's no demand at low price into a storage, and then you sell it at higher price when there's a demand. So if this is allowable into the grid, there would be more business model into the system. And you can expand that idea into not just only the stationary energy storage, but you can expand it to wheel to grid, grid to wheel, and then of course about the EV charging station. And there would be a fleet of them, not just only one or two. There would be hundreds or maybe thousands into the grid. So the way to manage this grid and the storage into the that embedded in the EV station could be a new business model. Another business model that would be very interesting is the demand response that could create what we call a virtual power plant, where if you send us a market signal someone who willing to reduce that demand at the peak period, and they be compensated economically by some pricing signal. If that would be allowed into the system, then I'm pretty sure that there will be more players come into this arena, and this has to change the regulatory framework, and definitely Thailand needs to shift away from the single buyer model to create more of the market-based model and try to introduce more pricing signal into the system. ขอบคุณครับ
Thank you, Dr. Tawarat. And I'd like to thank all the panelists. I think we have heard a lot of interesting issues through fruitful discussions that covering technical aspects as well as policy and regulatory frameworks. That might be able to, for the system, for the Thailand power sector to move towards the modernizing the grid to support the uptake of not only renewables, but also other emerging technologies, particularly electric vehicles. So we have heard the view from the main electric utilities in Thailand, EGAT, MEA, PEA, and also from the private sector, from Schneider, and also from the policymakers in the Ministry of Energy. So I'd like to thank all the panelists and for their fruitful discussions that we cover many issues in such a short time. Now I'd like to pass the floor back to Melsha just to give a closing remarks.
Dr. Pirapat and esteemed panelists, thank you ever so much for sharing these very valuable insights. I would like to take this opportunity to welcome you all to join us at this year's Future Energy Asia Summit, an exhibition where more of such topics are under discussion, which will help Asia on its journey towards energy transition and transformation. The summit will take place from the 25th to the 27th of August. But in the run-up to Future Energy Asia, we will continue providing critical forward-looking insights, which are super important for Asia's energy transition and transformation. The next one will be held on the 17th of June at 4 p.m. Singapore time. And the focus here, it will be a high-level financing dialogue with another added focus on renewable energy projects briefing. So on that note, thank you all very much again, and I look forward to seeing you all soon. Stay safe.
ขอบคุณครับ สวัสดีครับ
Thank you
ขอบคุณครับ
ครับสวัสดีครับ
ครับ
Thank you.